Stephen Hawking, a pioneer in our modern understanding of black holes, revised his theory on what happens when a star explodes and collapses on itself in a provocative paper published last week. Take a look.
The key was in the theory of black holes.
Now, here with more on why this is a big deal and what it means to us is Jerry Orris, astronomy professor at San Diego State University. Welcome to Evening Edition.
Thank you.
Now, Jerry, in the most basic of terms, what is a black hole?
A black hole is a region of space where the density of matter is so high that nothing escapes, not even light. And so the gravitational pull is just too strong for anything to get out.
And that's what we've been thinking of it for the last 40 years. But now Hawking says that may not be the case. What does his modified theory say about light and particles now escaping from black holes?
Well, the issue that Hawking and others have had lately is the idea of trying to merge the theory of quantum mechanics with the theory of general relativity, which governs, gravity. And so Hawking's new theory was black holes should normally destroy information. And Hawking has come up with an idea in which they basically they don't do that. And so instead of an event horizon that's well defined, the event horizon is more fuzzy or more chaotic.
And we're going to get to the event horizon, but I want to take a look at how Hawking explains his difference on black hole through this clip right now.
The calculations I was working on involved what happened to particles on the edge of a black hole that were sucked in and disappeared. To my great surprise, I found that some particles could escape the black hole, which seemed to make a mockery of the known laws of physics.
So now he says, okay, these particles can actually escape. And again, he's focusing on this event horizon. What is an event horizon and why is it important to understanding gravity?
So the event horizon is the boundary in space. It's an imaginary boundary. There's nothing physical there, but it's the boundary beyond which you cannot escape. And so if you're outside the event horizon, in principle, you can escape if you go fast enough. And once you cross the event horizon, you're stuck.
But now he's saying there might be some possibility of escape if you're in that event horizon?
There might be some possibility, like the matter can be hanging around what he calls sort of an apparent horizon just inside, and information can eventually get out, but possibly not in a useful form.
Okay, so a slight change here. What is the reason, I should ask you, why is it important to understand gravity?
Well, just in normal everyday life, things that we take for granted, like the global positioning system, relies on general relativity. And above all, we just want to know. I mean, the real basic reason is we just want to understand. And so black holes represent the most extreme states of gravity. And understand those, then you've really made progress.
Do you think it's possible if we did understand gravity, it could affect how we travel maybe in space, if we could harness gravity and use it to our advantage even here on Earth?
Possibly in the distant future, yes. But for the time being, it's more of a curiosity thing.
And understanding it. Well, since his paper came out, I've heard things like, is gray the new black hole? Things like this. What's the reaction in the scientific community over Hawking's theory?
Well, Hawking's actual paper did not contain that much details, and he's floated this idea before at conferences. And lots of scientists are very excited, and others are more skeptical. And we have to study more like what you might call the radiative properties. Is it truly black, or is light escaping, and what's the information contained? And so that's going to take a lot more work from the theorists to understand.
There's a lot more to be said on this. Yes. How will we know if he's right?
I've been thinking about that lately, and that's a really tough question. I mean, first of all the mathematics has to make sense at the very basic level, and I think that's not even there yet. But observationally, that will be a very difficult question, at least in the near future.
All right, well, a whole lot more to understand about this. Astronomy professor Jerry Orris, thanks so much for talking with us.
Thank you for having me.